Then we nibulate the fan with these bags of rice.
So once we had all the values from each value of each level of speed that the fan was able to give us, what we did was, thanks to the app, we put the values in X, in Y, and in Z. And then here we have the time in seconds, which we put that it will give us a date each second. It will be 1 hertz each second. So in this column we have the seconds, the X values, the Y, and the Z. Then the app, each value that it had, we had to multiply it by G, which equals to 9.81. The creator of the app who we use, each value was in correspondence to gravity, so that's why we have to multiply it. And the values that we actually care about were in Y, because it's the where it points, the direction where it points. It's the one who's gonna give us the angular velocity that we're searching for. Because Z, the position where the phone was, it was pointing towards to the wall, and Y is the one who was following and tracking all the velocity, the angular velocity we're searching for in this project. So also we multiply the values of X. Then it was really easy to look for this value. So we know for the formula that the acceleration equals to radius by w square by w square, and then we can derive from this that w equals to the root square of the acceleration divided into the radius. So we had those values. What we didn't have was w, so what we did was divide like root square of the acceleration divided into the radius, which was 58 centimeters. After that we got w for each value of the acceleration, and then we did our graph, and the graph is based between values in X in time and in w, and this is describing the acceleration is going to have w. It's describing w according to time in the low speed of the fan. We did the same for the medium one. We have our values, then we got y, and then according to the acceleration we got the w, and then we here have the graph for the medium speed, and last for the high speed we have this. And this is describing the movement acceleration w that it took our phone, the iPhone, according to the different 3 levels of speed. And here in this graph we have the velocity, that the angular velocity that each speed had, according this is the highest level of speed of the fan, this is the medium one, and this is the low one. We can see that each 3 of them, they actually descend. They have this curve of descending. This is where you switch off and the electricity goes off in the fan, and this is the time it takes for each of the 3 different levels to be from a continuous to having a constant acceleration, to stop having and then decreasing. This is how it increases all of its velocity. It increases. Then when you have a constant acceleration, when it reaches its highest point, you can see that there is no acceleration here, it just continues normal. And then when you cut off the electricity, when you switch off, then this goes down, the line starts going down, and velocity, the speed starts decreasing. And this is what we wanted to achieve with this project. We wanted to see how when you turn off a fan after having a constant acceleration, and this is how we prove it, then there's gonna be a curve that represents the descending speed. And this is what in instructions they don't show you. You know for sure that it increases until a certain point, and then it goes constant, but then you never actually think that of this line. This is what we wanted to prove, how it's actually descending, how many more revolutions are in this part of the fan, of the whole trip that our iPhone took.
Then here we have the angular velocity of the lowest level of the fan. Then here we have of the medium level of the fan, the integrals. And finally we have of the highest level of the fan, the integrals here.